The smallest and largest observations tell us little about the distribution as a whole, but they give information about the tails of the distribution that is missing if we know only the median and the quartiles. To give a quick summary of both center and spread, combine all 5 numbers. Okay, these 5 numbers are known as the 5 number summary. So what is that? It's the smallest observation, the first quartile, the median, the third quartile, and the largest observation. The symbols, in symbols, it would be the minimum, Q1, M for median, Q3, and maximum. These 5 numbers divide the distribution roughly into quarters. So a fourth of the data would be between the minimum and Q1, a fourth of it between Q1 and the median, and a fourth of it between the median and the Q3, and a fourth of it between Q3 and the maximum. This 5-number summary of distribution leads us to a new graph, the box plot, sometimes called the box and whisker plot. So how do we make a box plot? Well, the central box is drawn from the first quartile to the third quartile. Then a line marks the median, and the whiskers extend from the box out to the smallest and largest observations that are not outliers. Okay, so we're going to make a box and whisker and check for the data and all that. Here are the number of home runs that Hank Aaron hit in each of his 23 seasons. Calculate the 5-number summary from this data. Check for outliers, make a box, and compare Aaron's distribution with Bond's distribution, which is on page 91 in your text. Okay, once I put my data into ascending order, I found that the median is 34. The first quartile is the median of the first half of the data, which is 26. And the third quartile is the median of the second half of the data, which is 44. The smallest observation is 10, and the largest is 47. There are no outliers. The outliers would have to be less than a -1 and greater than 71, and there were no outliers. So this is what what the box and whisker plot should look like. Notice that the median is around 34. The first quartile is 26. The third quartile is 44. And this whisker will extend out to 10, and this whisker out to 47. I'm a little bit off there. This is a box and whisker plots that compare travel times to work for samples of workers in North Carolina and New York. We identify outliers as isolated points in the box plot, and there is an outlier. Box plots show less than histograms or stem plots, so they are best used side by side in comparison of more than one distribution. If we're looking at the shape, we can see that both distributions are right skewed. Notice the long tail. For both states, the distance from the minimum to the median is much smaller than the distance from the median to the maximum, and that is what we're looking at. The center, it appears that the travel time to work is generally a little bit longer in New York than North Carolina. The median of both quartiles and the maximum are all larger, and I couldn't get this to move up, but supposed to be up a little bit. The spread travel times are also more variable in New York, as you could tell by the length from the smallest number to the largest number, which actually is way out there. And the outliers is way out here, it's 85 minutes. So now would be a good time to stop and check your understanding. Okay, so find a 5-number summary for these data by hand. Show your work. The minimum is 307. The maximum is 353. The median is the average between 317 and 318, which is 317.5. Q1 is the median of the bottom 5 numbers, which is 311. Q3 is the median of the top 5 numbers, which is 326. So the 5-number summary is 307, 311, 317.5, 326, and 353. Calculate the IQR and interpret this value in context. Okay, the IQR is, remember that it is Q3 minus Q1, and that's 15. This is the range of the middle half of the weights of the Dallas Cowboy offensive linemen in 2009. Determine whether there are any outliers using the 1.5 times IQR rule. So, the IQR equals 1.5 times 15, which is our IQR, and that's 22.5. Any outliers would be below 311 minus 22.5, which is 288.5, or 326 plus 22.5, which is 348.5. There are no observations below 288.5. However, there is one observation above 348.5, and that's 353, and it is an outlier. And this is what your graph should look like, similar to this. Okay, real quick AP tip, the box in the box plot is not the IQR. The IQR is the length of the box. The 5-number summary is not the most common numerical description of a distribution. The distinction belongs to the combination of the mean to measure the center and the standard deviation to measure the spread. The standard deviation and the variance measure the spread by looking at how far the observations are from their mean. So, in the distribution below, how far are the values from the mean on average? Well, the mean in this is 4. And so, from 4 this way, it's a negative 3. And from 4 this way, it'd be 7 minus 4, which is a positive 3. And this would be 1 minus 4, which is a negative 3. These are the starting points for calculating the variance and the standard deviation. What does the standard deviation measure? The average distance of the observations of their mean. The average distance from each observation to the mean. Okay, so how do we find the standard deviation? Well, first you got to find the distance of each observation from the mean and square each of these distances. Then average the distances by dividing their sum by n minus 1. The standard deviation, and the symbol for that is s sub x, is the square root of this average squared distance. And this is the formula for that. Okay, so what are some of the properties of standard deviation? First off, it measures the spread about the mean and should be used only when the mean is chosen as the measure of center. it's always greater than or equal to 0. Standard deviation equals 0 only when there is no variability. This happens only when all observations have the same value. Otherwise, standard deviation is greater than 0. As observations become more spread out about their mean, standard deviation gets larger. It has the same units of measurement as the original observations. For example, if you measure metabolic rates in calories, both the mean and the standard deviation are also in calories. This is one reason to prefer standard deviation to variance, which is in squared calories. And fourth, like the mean, standard deviation is not resistant. A few outliers can make standard deviation very large. Okay, so stop and check for understanding on page 64. The heights in inches of 5 starters on a basketball team are 67, 72, 76, 76, and 84. Find and interpret the mean. The mean is 75, and that is, if the total of all the players were the same height, they would each be 75 inches tall. Make a table that shows each value, its deviation from the mean, and its squared deviation. Okay, so these were our observations. Remember that to find the deviation, we need to take the observation and subtract the mean. And so we get -8, -3, 1, 1, and 9. The squared deviation is when we square all those numbers and get 64, 9, 1, 1, 81 for a total of 156. Now remember, this is going to subtract to 0. Or add to 0. Show how to calculate the variance and standard deviation from the values in your table. Okay. So, the variance is the sum of the squared deviations. So that's 156 divided by 4, which is the number of observations minus 1. Remember, that's n minus 1. In this case, that means that the variance is 156 divided by 4, which is 39 inches squared. Remember, these are our squares. The standard deviation is the square root of the variance, and in this case, 6.24 inches. So interpret the meaning of the standard deviation in this setting. The player's height vary about 6.24 inches from the mean average of 75 inches on average. We now have a choice between two descriptions of the center and spread of the distribution. We can use the median and the IQR, or we can use the mean and the standard deviation. Because the mean and standard deviation are sensitive to extreme observations, they can be misleading when a distribution is strongly skewed or has outliers. In these cases, the median and IQR, which are both resistant to extreme values, provide a better summary. What factors should you consider when choosing summary statistics to use? The median and IQR are usually better than the mean and standard deviation for describing skewed distribution or a distribution with strong outliers. Use the mean and standard deviation only for reasonably symmetric distributions that have no outliers.